Hey, welcome to the BCST 2222 Instructional Cave. Let's see what's on, shall we? Okay everyone, welcome to BCST 2222. We're going to talk today about RAW and what RAW video files are and how you can use them. Okay, so what is RAW? Well, first off, what RAW isn't. It isn't a picture or movie file format. It's not something you can view. It's not a codec. It's a file format that is produced by the camera's sensor. It's just a data dump. That's all it is. It's just numbers. It is not debayered, has not been Bayer decoded. So all the Bayer filtering information is still imposed on the picture as it was captured. So that'll have to be dealt with. What it is though, is it is all the image from the sensor, straight off the sensor. No processing involved, just a complete dump. So the most amount of data you can get. No processing, no codecs, just numbers representing the luma and chroma values of a scene. Which makes this quite handy because you have all the data you need. Nothing's been lost in compression at this stage. RAW files are accompanied with a sidecar file which contains all the metadata, the time code, aperture, all the image data that came along with that video frame, but it's a separate file from the RAW. There are two files. They do travel together. Since RAW isn't encoded, there's no spatial or temporal compression along with RAW, because of course it is just that raw data. So let's just quickly recap for those that may be confused already. There are two ways to record video. One is to use a recognized compression scheme, such as AVC HD or MPEG to record audio and video, like most cameras do. Still cameras would shoot JPEG, for example. The other way is to capture the data directly off of the sensor and combine it with some metadata and store the result. And that's what RAW is. Let's watch a video from Wolf Crow. So RAW is not an image file. RAW is not an image file. Think of RAW as the data needed to make an image file once it's been processed. It requires special software to view, and in fact, when I say view, you can't actually view it, you've got to convert it. The moment you convert a RAW file at any point in the process, you're changing stuff, and some of that change is permanent. So be careful. However, you keep the RAW file. The change is made to the copy. You don't actually affect the RAW file, and therefore you can always go back and do it again if you don't like the result. RAW files are proprietary. They're specific to each sensor because each sensor's manufacturer gives off different amounts of data in different formats. So there's no such thing as a universal RAW. It does exist, of course, for still image cameras as well. Any sensor can really cough up RAW data if the software in the camera is written. Let's understand that all sensors produce raw data, but not every camera passes that raw data on to the memory card. A lot of them process it before it gets there. RAW files have at least 8-bit color depth, which is handy. They're low compression because, of course, it's right off the sensor, so the only compression is that sensor capture compression that we've talked about before. It's not lossless because remember that data is lost at the point of capture, either by the sample rate, the frame rate, the color subsampling at the sensor, whether or not the Bayer filter is applying, and of course Bayer filters don't recapture all the color at all the pixels. So there is going to be some data lost anyway, but RAW is the one to save the most data. It loses the least. However, a RAW file has all the data from the sensor, so it's lossless in that respect. RAW is higher in dynamic range because, of course, nothing's been done to the file. It's as the dynamic range of a RAW file equals the dynamic range of the sensor itself, more or less. Lower in contrast, the files that come out of RAW are flatter and washed out, and they're not as sharp because they haven't been processed. If you convert a RAW file in a player, you're going to see a lot of the data that is added by compression schemes, such as the sharpness and the edges, missing, and you'll have to add that yourself. RAW is not suitable for air. In other words, you can't just simply take a RAW file and present it. You're going to have to do some post to it. So if you decide to shoot RAW, that means that you have to make the decisions that are made in the camera, such as when a camera decides to shoot MPEG or AVC HD, a camera is making decisions and is applying those decisions to the final output. In the case of RAW, you're telling the camera, don't make any decisions, I'll make them. So that decisions still have to be made. Work has to be done. You're just moving the work outside the camera, which of course has its advantages and has disadvantages as well from time. RAW files are read-only. They cannot be altered. They can only be copied. As I was saying before, when you transfer them and make changes, you're making changes to the copy. The original RAW file is unaffected. Run a RAW file through a viewer or converter, and you will see that if you compare on the left the RAW file, which is unprocessed, off the sensor, processed in the sense that it's been put through a RAW file converter, but no codecs have been applied. No color correction, no color information has been applied other than what the sensor provided. And then look at the right in the JPEG and see how much sharper and brighter it is, because, of course, the JPEG codec takes into account the camera sensor's weaknesses, the camera sensor's sensitivities, and adjusts the file accordingly, right? So all these things will have to be done manually after the fact if you shoot RAW. Let's watch a video about RAW and see what RAW looks like. Remember, once you've converted a RAW file in software, they're no longer RAW. The file you've made with the RAW conversion is now a different kind of file and is not RAW per se. The RAW file, unviewable camera sensor data. The new file is some kind of RAW conversion. I say some kind because there's a number of proprietary, again, RAW converter programs, Sony, Arri, Red, Blackmagic. They all have their own file conversion softwares that make various and different outputs depending on what they provide. You can compare MPEG to RAW by saying that an MPEG file is a standard format readable by any program on the market, typically 8 to 10 bits of color, compressed, and a fairly small file size compared to RAW. MPEG is lower in dynamic range, higher in contrast, sharper, again, immediately suitable for viewing, sharing, or posting. So if you're a DIT and you're working with files that are RAW, you'll have to do an extra step before you can send or share those files with anyone. And most MPEG files don't need color correction most of the time. Unless, of course, you've made errors in the camera. There's nothing inherent about MPEG that requires correction. Of course, if you're going to manipulate MPEG files, data will be lost each time you make an edit. And the final note about MPEG is that it's processed, usually created in the camera. So if we remember back to when we talked about Bayer filters, remembering that not every pixel captures every color, as I've hinted at before, with RAW, you're going to have to deal with taking that Bayer pattern and de-Bayer it. And that is, again, a step in the RAW process. Software will give you options on how to de-Bayer files. This course isn't deep enough or long enough to give you the kind of detail you're asking for as to how, because different software is different. Every camera creates, digital cameras create RAW. Is it true that every digital camera creates RAW? Yes, but many of them you can't get at them because they are converted immediately before even being written to disk or SD card. So even though the sensor produces RAW, you can't get at them. RAW is proprietary, as I said before. Every company's RAW file is a different file because every company's sensor, and not just the sensor, even if the sensor is made by the same manufacturer and used in different cameras, how that camera manufacturer implements that sensor will affect the output and the RAW file accordingly. So you will need to have different conversion software in your quiver. Or you can use programs like Adobe Premiere, which will have some RAW conversion software, but be careful with some of those general purpose RAW converters. They can be harsher on the file than ones specifically written by the manufacturer. GoPro RAW is different from Sony RAW, which is different from Canon RAW, which is different from Red RAW, and so on. So the other thing about RAW files, it's kind of bizarre perhaps, is that they can change, the file formats can change because they're proprietary if sensor firmware is updated. So if you download an update for your camera and the sensor update includes some change to the RAW file format, then the RAW files that camera produces will be different than they were before the update. Blackmagic has done this before. So RAW is not uncompressed. So many RAW files are compressed. They're not all uncompressed RAW sensor dumps, just because, again, the files are huge. Red Code RAW is compressed anywhere from 3:1 to 18:1. Sony's f/65 Super 35mm is 3:1 to 6:1. One company that doesn't compress their RAW files is Arri, their Alexa. RGB video, each pixel contains information which of course would be large with a 16-bit depth, so video is usually limited to 8 or 10 bits to preserve file sizes from being too large. RAW can be 12-bit, 16-bit, or even 24-bit, depending on the sensor. So again, just to recap, what do you need to use RAW? You need plugins, applications, viewers, and converters. As I say, beware Adobe Premiere because RAW import is not quite what it seems. Premiere will bake in some settings and therefore it may be undesirable. Another option to use besides RAW is something called log. Log is a video format that mimics some of the features of RAW, but preserves things like contrast and sharpness and aperture, but it's also a video format, so log files can be viewed and sent and watched on a monitor. So there are many kinds of logs as well. Log is as proprietary as RAW. Sony has S-Log, Canon has Canon Log, Arri has Log C. They're proprietary again because they're manipulating the raw data to create a log file, and so they're designed for specific cameras. Log uses a gamma curve that pulls most of the information off their sensors, and by gamma curve what I mean is we're changing the luminance response of a camera's sensor to better see details in shadows and highlights. The gamma curves are basically the difference between the graph that the camera's sensor produces when it comes to linear response and the actual graph. And here's an example of gamma curves. You can see that on the left with the uncorrected gamma, this is straight off the sensor, the stair steps aren't even. If at the top left, you'll see the first 3 bars are much darker than the next 3 bars, then the next 3 bars, and then finally we have very little difference between the last 2. Compare that with the adjusted gamma curve where we've tweaked it a little bit, and now you'll notice the stair steps at the top right are even. Each step is 1 step below or above the next. Much smoother transition from tone to tone. And that's what a gamma curve will do. Because a log is a video file format, some of the things are baked into it, such as white balance and ISO. RAW files have no white balance because white balance is something you tell the camera after the sensor sees the image and the raw data is off the sensor. Log does allow for a wider control over the tonal range, which means you've got much better adjustments of shadows and bright areas and color saturation, for example, than you would with MPEG or any other compressed format. In order to transform a log file into a usable final product, you need to use that lookup table, which again we'll talk about some more. But this is where you can assign colors to their proper locations, comparing them from the sensor, what the sensor is recorded, and compare that to what the world is actually looking like. A standard LUT, for example, would convert log video to HD video, Rec 709, and we'll talk more about LUTs. And then there's a couple of proprietary options. One of them is Cinema DNG. This is Adobe's version of log, because Adobe doesn't make cameras, of course. So what Adobe wants to do is try and persuade them from the post-production end to use a file format that they've created. At the moment, Premiere is the only software that uses Cinema DNG that I know about. It has the same issues as log does versus RAW in that some things are baked in, and you may not like that adjustment because it's unchangeable once you've done it. Remember, one of the things that limits log and RAW is the files are big, and so as processors get more powerful and memory gets cheaper, in cameras particularly, more so than in laptops, more log formats may pop up. The amount of processing required in a camera to make some of this stuff is pretty big, so you don't see it often in smaller, cheaper cameras. And remember, log is also somewhat proprietary like RAW to keep you in the family of equipment. Okay, that concludes the lecture on RAW and log. Thank you.